All right, on page 2, in pre-calculus you learned some basic truths about rational functions. Rational just referring to fractions. So when a factor is canceled from the denominator, a whole occurred. All right, that's when you factor either the denominator or numerator or both, and then wherever your factors cancel out, whatever made that 0 in the denominator is going to represent a whole. And then number 2, when a factor would not cancel, you have a vertical asymptote, right? That's a non-removable discontinuity. Okay, so this part we've actually already seen before in class, so I'm just going to run through this really, really quickly, okay? Basically, you look at the top, factor it out if it's factorable, take a look at the bottom, factor it out if it's factorable, and then figure out where your discontinuities are, right? Whatever is going to make the denominator 0. And then we're going to take a point that's either to the left or to the right of whatever is causing that discontinuity, okay? So if we take a look at A, I'm just going to factor the top and bottom. I'm going to go quick through this stuff, all right? So you can use whatever strategy you want, either slip and slide or grouping, or the basic ones, you know, all the strategies that we've learned throughout the years, okay? All right, so in A, the limit as x approaches 4 from the left, the first thing in the numerator, I'm just going to pull out a -2, and then once you factor it, it should be x plus 3 times the quantity x minus 2, and then the bottom is just a basic trinomial, so it's going to factor as x minus 4 and x minus 2, okay? All right, so a couple things are going to cancel here. So we know that x minus 2s are going to cancel, so at +2 there's going to be a whole. And then the rest of this stuff, we're just going to kind of leave it here. So we have the limit as x approaches 4 from the left of -2 times x plus 3 over x minus 4. Okay, a couple things to notice. So there's a whole at x equals 2, okay, but for this particular limit, since I'm looking around 4, it doesn't really matter, all right? So the fact that it canceled, you have to recognize, or you should recognize, what type of discontinuity it is, all right? It's a whole or a removable discontinuity, but because of the context of where we're looking on this limit, it doesn't really matter, all right? What matters is 4, and 4 is giving me an issue in the denominator, okay? All right, so we're only looking to the left of 4, so I'm just going to pick, we'll check x equals like 3.9, and then we'll see if it's positive or negative. So if you plug in 3.9 and just check the signs, we end up with a negative value at the top, a negative value at the bottom, and overall this would be positive, right? So this limit must equal positive infinity. All right, so this stuff you've seen before for sure. All right, part B, we're going to take a look. Is it the same function? Yes, it is. Okay, so we'll take a look from the right. So we'll check when x equals 4.1-ish, something close. So negative at the top, positive at the bottom. So it's going overall to negative, so this is shooting to negative infinity. All right, so in part C, the only thing I can factor here, I think, is a 2 in the bottom. So the limit as x approaches 1 from the left. If you factor this, is that even factorable? 5, no, so you can't factor the top. But we can just pull out a 2 in the bottom. Yeah, because 5 is just, what, 5 and 1, right? There's no way to get to 2, yeah, so that's as much as you could do. All right, so you're just going to check the value, so x equals 1 from the left, so maybe like 0.9. If you plug it in the top, it'll be positive. Plug it in the bottom, it's negative. Therefore, this is going to negative infinity as you approach 1 from the left. All right, and then same function, but just approaching from the right, so we'll check when x equals like 1.1. Positive at the top, positive at the bottom, positive overall, so that's shooting to positive infinity. All right, no big deal. Okay, so we've seen that before. So this is something that we've talked about, and I know that you guys know this, but I just want to make sure we have it written down somewhere. So there's two cases when you have a non-zero number over 0. That's telling you that it's an asymptote, right? You're getting some kind of division by 0. That is not an indeterminate form, right? So if you end up with like 5 over 0 or something, that tells you have some type of asymptotic behavior, right? So we're going to have a vertical asymptote when you have a non-zero over 0, right? But if you end up with 0 over 0, that's when things cancel and you have to factor or add fractions and all that good stuff. But essentially, that's the location of a whole, okay? That's when the factors cancel in the top and bottom. All right. So justifying this, I mean, I guess like you probably talked about this in pre-calc, but now that we have understanding of limits and limit notation, we can come up with this definition here. So the limit definition for a vertical asymptote is if the limit as x approaches c from the left is equal to plus or minus infinity, or if it's unbounded essentially, or if the limit as you approach from the right of the function is unbounded, then wherever you're looking is a vertical asymptote, right? This is kind of obvious, I think. Nothing that you couldn't come up with on your own, but we've never written it this way, okay? And this thing happened here on all of these problems, right? So when we're looking at these types of limits, we were looking at a particular number, so you're looking at 4 and at 1. And your answers became positive or negative infinity, all right? That's because you have some kind of asymptote, some kind of non-zero number at the top, and 0 at the bottom, all right?